So these Kepler potentially Earth-like planets are well and good, but they're 1,000 light years away. They're too far away for us to send space probes to or write into science fiction novels in the near future. What I'd like is some nice habitable ones close by so we can study them really well. But how are we going to find them? Kepler's not going to find anything that close.
Well, I think in the short term, maybe what we can do is use the radial velocity technique. And
That only finds giant things, typically.
well, it does if you look around big stars, but let's say we look around little stars, the smallest stars, and then the planet won't have to have that much mass to make a measurable, imprint on the velocity of the star.
So we're back to red dwarf stars again, and perhaps the most spectacular example is Gliese 667, which on the basis of its radial velocity seems to have 7 planets around it. At least
7
you
planets.
need 7 different sine waves superimposed. Not all of these are completely sure. I mean, that's looking a bit marginal over there. Maybe this one. But as they get more data, they hopefully will be able to nail this one down more accurately.
All right, but any Earth ones in this one?
Well, this is a really weird system in more ways than one. So we've got the red dwarf here, but it turns out the red dwarf is actually in a distant orbit, about 300 astronomical units out, from a binary pair of brighter stars.
Ah.
So you've got the bright stars, and then you've got the red dwarf orbiting much further out, and the planets all going around this red dwarf. So this is what the night sky, and it looks like the two of these things, E and F, might be potentially within the habitable zone. And so here's an artist's impression of one of them, and showing the red dwarf, which look quite large. You're very close in, but because the red dwarf only puts out 1.5% the light of the sun, you've got a nice temperature, and you can see the other 2 stars in the background on this, so giving you the interesting triple sunset.
Okay, sort of like something from Star Wars. That's nice. Nice lakes.
Well, of course, we have no idea if it's got lakes. All we know is the mass. I mean, it could be a black hole.
So, okay, so this is star E. Does star F look equally compelling?
Well, this is discovered by telescopes at the European Southern Observatory, and they've put together the simulation of what it might look on the next one out, and they're guessing this one might be a bit like Mars.
Okay, so this is the first one we just saw with the lakes, and this one is Mars-like. Unfortunately, we really are at science fiction here rather than science, but it's at least nice to speculate.
Yeah, I mean, these things are very big. Their masses are a lot of Earth masses out there, and so we don't know anything about them really. This is about 20 light years away.
Okay, so I know that there are a handful of stars which really are close. There's Alpha Centauri, there's Sirius, there's a few other stars that are within 10, 15 light years, where we could imagine getting to within a few 100,000 years in today's spacecraft.
And one of them, Tau Ceti, does seem to have potentially habitable planets. It's actually probably the closest Sun-like star, depending how widely you draw the bracket of Sun-like. It's only 12 light years away. It's actually quite a dusty system, so it's traces of maybe a little bit of a debris disk. And it's not a red dwarf, but nonetheless, because it's so nearby and so relatively bright, you can get very high precision radial velocity measurements. And this is claimed, it's a controversial claim, that it maybe have 4 or 5 planets, 2 potentially within the habitable zone.
I actually know one of the authors of this paper, and I was asking him about it, and he said, yeah, maybe.
Yeah, so I mean,
it's hard work. It's really hard work.
We're talking mass sin I. Remember, we don't know the inclination of these things, so this is a lower limit on the mass of between 4.3 and 6.67 Earth masses.
So it's either a lot of real estate or a giant balloon that's not much use at all.
Yeah, I mean, odds are these sort of radii we're talking about a mini Neptune rather than a super Earth, I would have thought.
Okay, but presumably this star is so close that we have a chance in the future of maybe even looking at these planets directly from Earth with the new telescopes of the future.
Yeah, this might be a good target for some direct imaging. I mean, this is much closer in than what we're seeing so far with direct imaging and much older, but because it's so nearby, maybe we've got some sort of hope.